Alright. Hi everybody, welcome to the stream. Today is going to be a very short stream. I know I'm streaming pretty late, but we're here to just continue working on the effect stuff. And I realized I ran into a problem. The problem I ran into is that we have to call among all our different effects, which are all over here, by the way. These are different effects that exist in the game. We need to be able to call their update and draw functions appropriately. And because we have to do that, we run into this issue where we relied on the polymorphic properties of these objects. So originally I was thinking, okay, well, how are we going to do that without pointers, right? Because you need pointers to access virtual functions, to get into the vtable, which will call the appropriate function, even if you just call it from its base class, yada yada. But I think we can still accomplish the same thing if we can manage to use like something like this. So I was looking at this and I'm like, oh, visit inside of variants might be useful, because we talked a little bit about variants yesterday, and it kind of allows us to do what we're looking for. So if we provide a variant with different types inside of it, then we can provide different functions which end up having different properties based on what the variant is. So that's kind of interesting and might be the method I want to go. So today I want to explore that a little, because it's probably going to be the framework that we implement going into next week. So even though I was at a point where I'm like, okay, I have a system I want in regards to like having effect ref, which acts like a weak pointer or kind of like a mediator between an actual effect and the container that holds all the effects. And that's all great, and that all works, and that system's fine. But what I need is something that allows us to take, based on the variant type, a function and execute it differently based on that. So in here, again, we have a class B and a class C, and I'm actually going to make that they're deriving from class A. So in class A, I'm going to make a function called printme, right? And the printme function is just going to be, well, it can really be anything, but I'm just going to have them print out like what letter they're calling, right? I think this is pretty typical if you're like experimenting with like derived classes or something. Now my question is, can we take this function and say we want to call this function from elsewhere, right? Like let's say we had stored some kind of standard function that returns a void and accepts, well, a void as well, right? It doesn't accept anything. So we have something like this, and we just say my function equals, and we say a print me. Are we allowed to do this? Convert from void. Okay, so I guess this would be what it would look like under like a type. I forget how you do this, right? It's basically a function pointer. Trying to remember how you would do this. Let me look up function pointers. Function pointer. But I think that's like the idea, right? Or maybe a way to get a standard function out of it. Like, would there be a way to call that or convert that? Or would I have to store that in something else? I guess that's what we're really looking for. Pointer to member functions. So, pointer to member function f of class... Oh, I think you might include this, don't you? I think that's part of it, but the other part is actually using the right syntax, right? So, it's like... void... let me see. It would just be Is that right? Hold on. I'm not sure how you're supposed to do this. Let me see. A pointer to non-static member function f, which is a member of class C, can be initialized with the expression in C::f. Exactly. Expressions such as that or f inside C's member function do not form pointers to member functions. Such a pointer may be used as the right-hand operand of the pointer to member access operators. The resulting expression can only be used as the left-hand operator. Let me see. Can we assign member function to standard function? Is that possible? Because that would be the easiest way to do it, right? A non-static member function must be called with an object. That is, it always implicitly passes this pointer as its argument. Because your standard function signature specifies your function doesn't take arguments, you must bind the first and the only argument. Oh, I see. Well, that kind of makes sense. If you want to bind the function with parameters, you need to specify placeholders. Or if your compiler supports... Oh, I see. Lambdas too would work. I mean, that's very fair, right? You would just make something that calls print me, right? That would be one way to do it too. I guess that makes sense. If it was the right type. So it'd be like standard bind. Let me undo that and do like standard bind. And then, but then you have to bind it to a certain object, right? So it would be like binding it to a... yeah, okay, I see what's going on there. So the functions I would have to make would have to be like static functions that accept an object, or if they are member functions, we need to accept those going into it. So it would look something like... I want to do standard visit, but let's try this, right? So we would have, like, for example, a standard variant containing A, B, C. And this would be inside of vector, right? So we have vector of these kinds of variants. We call these objects. And then when we iterate through these, it would be like this. I'll just say auto here. Object inside of objects. Then we would do something like object or... Let me go back here. Visit. Is this like... Am I in the wrong place? Let me see. Const auto visitor equals overloads. So you would make the overloads yourself, like so, and then you would call visit on the visit. Oh, we have a standard visit, because I think I didn't see that, the 26. So we would use standard visit since C++ 17. Okay, that's very fair. So standard visit overloaded by iterating through like that, right? So it'd be standard visit callable. So overloaded. Well, overloaded is what? Helper type for the visitor number 4. Using TS : operator. Okay. The variant to visit is value T. Void visitor, value returning visitor, type matching visitor. Another type matching visitor, a class with 3 overloaded operator. Okay. The auto arc template operator will bind to int and long in this case. But in its absence, the double arc will also bind to int and long because both are implicitly convertible to double. So, compared to this, again, I see there is like a helper type thing again. So I guess we could try it and see what it gives, right? Because it's like the same idea. We just let P right here. So that overloaded then contains a bunch of your functions for object. Okay, so now we would have to fill these in with different types. Like it would be like A object, B object, C object. So it looks something like that. I guess this would be reference, maybe. But yeah, I guess that would be like the idea. And then with those, you could do something like... I don't know, would we just then write it in here? Because obviously these would do different things, right? Like this one would do print me, this might just change a variable, right? It also has a print me, but if we were to override it, it would say something else, right? Like, could these all do the same thing, technically? I mean, in that case... That's interesting. And it would end up calling, like, an overwritten version if it was virtual? I wonder. Because that's interesting, right? And let's just make some test objects. A, B. Or something. Okay. And then I assume if we debug it, we'll end up hitting one of these lines. So here we hit A, and then B. So that does indeed work in the sense of it goes to the right place based on what the type of the object is. So we can call its corresponding, like, function from here. Okay. I mean, I like that. That's not terrible, right? It's like basically... Like, I wonder how this is... I guess this is not really much different from a switch statement. If we were to do, like, a switch statement with a type, it's just the type of the object is being used versus having a separate enum. Hello, what's on the plan for today? Well, the plan was to mess with this visitor pattern to see if maybe I want to use it for my game's effect system, because we've run into an issue where at least game effects, game particles, are currently allocated on the heap. But the way I designed it was I actually made it so different effects have different behaviors, which ends up being a problem because originally I was going to use polymorphism inheritance, but if I want to avoid heap allocating, it means I can't use pointers, which means I can't use polymorphism. So I either need to convert every effect into something else, like kind of like I have my monster strategies where we define a bunch of functions based on like the name of the effect or something, or I need to potentially use like a visitor pattern instead, which would then allow me to still keep this like inheritance structure, but instead I would be able to use raw objects allocated on the stack. So that's kind of what we're just brainstorming today, because yesterday we were starting to work on it, but then I realized, okay, well, what happens when I get to the part where I have to actually call an effects update function? I'm not going to be able to know which update function I need to call, considering these are inheriting from one another. So then I'm like, okay, are we gonna carry the type information as a separate variable, like use an enum? Are we going to switch completely to like having a bunch of static functions declared and then call the right one based on like a name, store them in a map or something? So, but then I'm looking at this and I'm like, this isn't so bad either. If we have a place where we store all the different updates per object type, that's not a bad idea. Like, I assume with these, I can then take these and break them out somewhere else, right? I don't have to necessarily store them here. I can just say, okay, this is a standard function, void b, in this case, a b ref. That's not right. That then is called bprint. And it would look like that, and then I can just put a bprint in here. Like, I assume I can then store these somewhere else, and I can split them up into like neat files or something. That way I'm not cluttering up everything in one place. But yeah, I think that might be the idea. My brain says template specialization might help you, but I don't think I understand the pattern enough. Template specialization. I guess that's effectively the same thing. Because if I say like, okay, we have a... Well, I guess the issue we run into is how do we determine the type? So it's like, we have a... Even if I put them in a variant, I can't necessarily get the type, so I can't really know which function to call. Which is why the standard visit function kind of accomplishes that for me with a variant, which is kind of nice. It's like, we don't know what the type is, given we're storing them as... Even if I store them in a vector of variants, I don't know which type the object is going to be. I guess technically I do if I know the index, but then I would have to make a switch statement that says, okay, if you're this type, go do this, etc. So that doesn't work either. I wonder if these can be in any order too. I assume they can. So that's kind of cool. Because templates have to be generated at compile time, but we don't know, like, there's no defined order or requirement for which object belongs in which slot in a vector, or in this case it's going to be an array, but just using this for testing purposes. So yeah, I was looking at the visitor pattern because I've heard about it a few times, and I thought maybe it might be a decent solution for this. And it's a step we can go. It looks okay, it looks flexible enough to use. So I might do it that way. I don't really see many design flaws with this, other than standard variant be a little expensive in terms of memory. So for each variant we add into variant, we are increasing the size. So like, yeah, a variant contains the total size of every single structure that you add to it. So, which is kind of unfortunate, but it is what it is. I guess that's the only real downside, but then a lot of the hard stuff is automated for me. The only thing I would have to do if I were to add a new object is define it like before, add whatever I need in here, and then write the code in. I'd probably make these into separate files just like I would for a normal class, and it would look something like yeah, instead of like lightning bolt update, we might do, well, we might still be able to do something similar to this actually if we make it like, we might be converting everything to static functions, honestly. But like, it would probably look something like that. And then that can just be stored in a lambda or something. Or no. No. There's a way to do this, but I'll figure that out. Like, that's gonna be the next step, is how do we go from that to what we currently have over here? So that's gonna be interesting. It's like, I have to define the variable somewhere. So it would be like, it's like we would have a function called like lightning bolt update as an example equals, and it would be a lambda containing the, in this case, the effect object itself, but it would be called lightning bolt. So maybe this becomes like a small macro or template or something, which contains the effect reference in here, and then everything else follows just by the design of it like this. I think that's kind of where we're headed. So yeah, just brainstorming today. It's not really much, but I had to jump onto my computer and give it a little whirl and a little playtest. So I think I'm happy with this. It's definitely a step in the right direction, and so I think we're gonna go with that approach next time. And then all I have to do is stuff them all into this standard visit here, and it will be able to choose the right one. It's kind of interesting. Yeah, I like it. Because I would basically be doing the same thing if I were to come up with my own method of doing this, but I would be doing it manually, which would be a pain, I think. So I think this is the way we want to go. Again, standard variant will be a little big, but we can look at these structures and we're like, okay, I mean, we've got a vector here, we've got a couple floats and spools. It's like, these are still, relatively speaking, not the largest structures they could be. They do inherit from effect, which has quite a few things in it, but it's like, it could be worse. I think the data type sizes are manageable because we're only doing a max of 1,000. So you would think on average these are about 300 bytes each. 300 times 1,000, so about 300 kilobytes of memory. I could live with that. I'm not really complaining. Yeah. Okay. Mostly just a small discussion. Very, very short session, but I wanted to at least figure out, okay, what's the plan going on ahead? Because whenever we have to do a full, like, refactor and redesign, we have to know, especially with how much is already established here, okay, what problems are we going to run into? Is this a scalable solution? Is this the right solution? What are the disadvantages, right? The whole goal of this is to speed it up because it's heap allocated right now, and we're talking like spawning hundreds of particle effects hundreds of times per second. If you heap allocate that and delete them really quickly, yeah, we get the frame rate drops on release build that we were experiencing yesterday. I'm like, that's a no-go. if this is all stack allocated and we have a system, which is what I was working on yesterday, that says, okay, here's your create an effect, insert it into an available slot, and yeah, keep track of it, then effectively like a version of a weak pointer, but we're not using pointers. So also, yeah, we're probably not doing the standard any if we're gonna go this route, because obviously they wouldn't be standard any's, they would be standard variants. So the only downside with standard variant is every time I add a new type, I have to expand that list, so we would definitely be using a using there. Yeah, so I think we have a good strategy here. I think I'm gonna go with it. I'm convinced that this is a proper strategy. I just have to think, okay, what are all the changes I'm gonna have to make across the whole code base? It's probably going to be like a 2-day refactor, at least from the looks of it. We're gonna have to write some unit tests to make sure it actually works. And then, of course, if I run into any pitfalls along the way, we're gonna have to reevaluate. I like where this is going, though. Alright, cool. So, things to think about over the weekend. I'm gonna call it here, because it's time for me to go. I literally just had to hop on to experiment with that, but I'm glad it's produced something I could probably use, so I'm gonna go for it. So yeah, we'll prepare for that next week. But yeah, thanks for tuning in, Craigtown, and anybody else. Hope you enjoyed the short but informational stream, and we'll see you next time. Bye-bye. You too. Have a nice weekend.